The tragic story of Spanair Flight 5022, a crash that almost didn't happen on August 20, 2008. Tragedy struck just moments after takeoff from Madrid Barajas Airport. Spanair Flight 5022, bound for the Canary Islands, crashed, killing 154 of the 172 people on board. At first glance, the cause of the disaster appeared straightforward, but as investigators delved deeper, a tragic tale of near misses, human error, and ironies emerged. This is not a story about a pilot flying into a mountain or a plane catching fire. This is the story of a crash that almost never happened but did. This is the story of Spanair Flight 5022. The passengers and crew flight 5022 was a typical flight for holidaymakers. On a hot summer afternoon, 166 passengers and 6 crew members boarded the McDonnell Douglas MD-82 for the 3-hour flight to Gran Canaria. While most passengers were Spanish, there were also Germans, French, Italians, and others on board, all eager to escape the sweltering Madrid heat. The captain, Antonio Garca Luna, was a 39-year-old experienced pilot with more than 8,000 flying hours under his belt. He had served in the Spanish Air Force before joining Spanair, where he rose through the ranks to become a captain in 2006. Colleagues described him as disciplined, precise, and methodical in his work, though reports from his earlier training highlighted the need for improvement in communication and coordination with his crew. By the time of the accident, however, he had made significant strides in this area. The first officer, Francisco Javier Mulet, was just 31 years old and had joined Spanair the year before. With just over 1,200 flying hours at the time of the crash, he was still considered relatively inexperienced, but had gained a reputation for being diligent and hardworking. The aircraft itself, a 15-year-old MD-82, was a reliable workhorse in the skies. Though no longer in widespread service today, this model had been a popular and safe choice for many airlines around the world. The first takeoff attempt. The drama began just before 1:30 p.m., when the pilots prepared for takeoff. However, shortly after receiving clearance, they radioed the control tower, Madrid, Spanair 5022, "Look, we have a slight problem. We have to exit the runway again." They had noticed an issue with the RAM air temperature rat probe, which was reading a higher than normal temperature. The rat probe is critical for managing 2 major functions on the plane: controlling the anti-icing system for the wings and regulating engine power during flight. A faulty reading from the sensor could lead to a reduction in engine thrust, which would severely impact the plane's performance during takeoff. So, the pilots decided to return to the gate for inspection, ensure whether it was safe to take off with the sensor malfunctioning. A delayed departure. Back at the gate, the crew was under increasing pressure. The sun was baking the aircraft, and the temperature inside was rising. As maintenance technicians worked to solve the problem, the crew discussed various fixes, including the possibility of using dry ice to cool the probe. Time seemed to drag on. Passengers grew frustrated, the cabin became stifling, and a sense of urgency began to build. Over an hour later, the crew decided to pull the circuit breaker that controlled the rat heater. However, this did not resolve the issue. The crew, now feeling the heat both literally and figuratively, was eager to get airborne. A rushed checklist and aerosauce. They prepared to depart. The pilots made several crucial mistakes. Under the mounting pressure, they rushed through the pre-flight checklists, overlooking critical steps. The flaps, which helped the plane take off smoothly, were not properly set. The automatic reserve thrust system TOS, which would have alerted the pilots if the aircraft was not properly configured for takeoff, failed to activate, likely due to the same electrical issue that had affected the rat sensor. The crew's rushed mindset and failure to adhere to procedure would prove catastrophic. As they lined up on the runway, the first officer failed to notice that the flaps were not set correctly, even though the indicator on the cockpit display showed 0 degrees. This oversight was compounded by expectation bias, where the pilot saw what they expected to see, rather than what was actually there. The captain, distracted by the task of lining up the aircraft on the runway, was not fully focused on these checks. And so, when the time came to take off, the aircraft was not configured properly. The fateful takeoff with the engines roaring, the plane accelerated down the runway. As it reached 157 knots, and the aircraft became airborne, disaster struck. The stall warning horn blared, and the aircraft's nose pitched up at an unsafe angle. The first officer, initially thinking the engine had failed, reduced power to the engines, but then immediately pushed the throttles forward again. It was too late. The plane began a sharp right bank and failed to climb properly, only reaching about 40 feet above the runway before its tail slammed into the ground. The aircraft slid along the runway, plowing through an embankment and bursting into flames just moments later. In a span of just 10 seconds, 154 lives were lost. The investigation and findings. In the aftermath of the crash, investigators uncovered a complex series of failures, both mechanical and human. The crew's failure to deploy the flaps, a crucial step for a safe takeoff, was identified as the primary cause of the accident. However, the deeper factors that contributed to the crash were rooted in a series of compounded issues: faulty sensors, rushed decision-making, mischecks, and a breakdown in communication between the pilots. One of the biggest ironies of this tragedy is that the malfunctioning RAT sensor had been an issue on previous flights without incident. The crew's decision to turn back to the gate, motivated by caution, set off a chain reaction of delays and mistakes. In their attempt to be extra cautious, they inadvertently created the conditions that led to disaster. The takeaway final investigation report made several key recommendations to prevent such a tragedy from happening again. Regular testing of the tows before each flight, especially on MD-80s and similar aircraft. Improved aircraft certification to ensure that a single fault cannot disable critical safety systems like tows. Enhanced training for pilots, particularly regarding stall recovery and maintaining focus on crucial checklist items under pressure. The report also highlighted the importance of crew resource management, emphasizing the need for pilots to remain disciplined, even under pressure, and to avoid distractions that can have deadly consequences. Spanair Flight 5022 is a stark reminder of how a series of small, seemingly insignificant mistakes can lead to catastrophic consequences. In a high-stress, time-pressured environment, the crew's adherence to procedure was compromised, and the plane's faulty systems failed at the worst possible moment. The story of this crash is not just one of technical failure, but also of human fallibility. It's a tragedy that could have been avoided if only the system had worked, and the crew had not rushed through their checks. But in the end, it was the combination of all these factors that made Spanair Flight 5022 one of Spain's deadliest aviation disasters.